Okay, so again, same consistent steps. I think it's really important that we use consistent steps because that way, no matter what the question looks like, we always can kind of attack it in the same way. So our first question is this proper? Well, the degree of the numerator is 2, right? Is 2, and the degree of the denominator is 2 times 1, excuse me, 2 plus 1, which is equal to 3. So yes, it is proper. So we want to factor our denominator, right? So we've got x squared times x plus 1. Really, it is factored. If we want to think about the decomposition, we're going to break it into, we have x squared, and x plus 1. And again, the goal here is to consider every possibility of that multiplicity, right? I'm not claiming that this is equal to this. That's not the claim. It's just the potential breakdowns of the denominators that we'll have, okay? So when we set up our decomposition, we've got 4x squared plus 2x minus 1, and that divides by x squared times x plus 1. We get 1, 2, and 3 fractions. And again, just to kind of emphasize, when we have x, what we're talking about is the factor x plus 0. And when we have x squared, we're talking about it's also a linear factor, x plus 0 squared. These are both linear, okay? So they do not get ax plus b or bx plus c, whatever the formatting is. They are considered linear. So you've got a over x, that was our first one. You've got b over x squared, and you've got c over x plus 1. Okay, those are your 3 breakdowns. So now we want to multiply by the least common denominator, and that least common denominator is x squared times x plus 1. You can break it into x times x if you really want to, but I don't necessarily think that's needed here. 4x squared, 2x minus 1, x squared, x plus 1, a over x squared. Okay, so if we multiply by this LCD, cancels fully, right? Okay, so canceling here, we're canceling one of the exponents with the denominator, fully canceling x squared with the denominator, and canceling x plus 1 with the denominator. So again, be very careful with your canceling. Make sure that part is done correctly. Okay, so we've got simplify. I guess you could add another step of solve if you really wanted to, but not necessary. Plus 2x minus 1 equal to ax times x plus 1 plus b times x plus 1 plus c x squared. We're going to continue simplifying. So you've got ax squared plus ax plus bx plus b plus cx squared. So we're going to group these just like we have in the past. We've got ax squared and cx squared. That'll get paired up with our 4 in just a moment. We'll rewrite it fully, but and then we've got our x terms, and then we've got our constants. So let's pair these up. 4x squared, a plus c x squared, plus 2x, a plus b times x, and then minus 1 plus b. And those colors should be updating. I don't know why it's doing that today. There you go. Okay, so let's set them up as equations. You've got a plus c equal to 4. Again, this is the fact that we're kind of referencing, that if this polynomial is in fact equal, that means that the coefficients of like terms on either side of the equal sign need to be equal to each other, right? It's the only way that this remains an equal equation. That also means A plus B is equal to 2, and it means B is -1. So there's your system. We do have one of our answers already. So A, B, C. B is -1. So this gives us, really, I can just substitute, right? So A plus -1 is 2. We add 1 to do the opposite, and A is 3. There's 2 of your values. And then we can plug that into the first one. So that's 3 plus C is equal to 4. We move our 3 over, and it means C has to be 1. So A is 3, B is -1, C is 1. Okay, so now we want to group these together and plug them in. So here we are. So if we plug this in, we've got 4x squared plus 2x minus 1 divided by x squared times x plus 1 is equal to 3 over x plus -1 over x squared. Again, you could write -1 over x squared. This just tends to be the formatting. Plus 1 over x plus 1. And that's it.